Alright, this is part 4 of the 2.3 notes, the last part. Here we're talking about the intermediate value theorem and then just graphing a polynomial. So the intermediate value theorem, what it basically says is if you plug in two numbers, and those two numbers aren't the same numbers, and you get opposite signs, like one output's positive, one output's negative, or vice versa. Because these polynomials are continuous functions, then it has to be the case that there's some number in between those two x values, inputs, where the output at that particular number is equal to 0. So meaning like if this is positive, this is negative, somewhere in between those two numbers, we had to cross over and go from negative to positive or positive to negative. Alright, so let me show you what we mean by that. So how do I show that this function has a 0 between 2 and 3? I plug in 2 and I plug in 3. Okay, if I plug in 2, I cube 2, I subtract 2 times 2, and then I subtract 5. So 2 cubed is 8, minus 2 times 2 is 4, minus 5. Alright, 8 minus 4 is 4, 4 minus 5 is negative 1. So I get a negative number when I plug in 2. Alright, when I plug in 3, I cube 3, I subtract 2 times 3, and I subtract 5. 3 cubed is 27, minus 2 times 3 is 6, minus 5. Alright, and then 27 minus 6 is 21, minus 5 is positive 16. So this is negative, this is positive, so somewhere in between 2 and 3, because it's a polynomial and it's continuous, we had to cross the axis. Alright, so again, let me remind you, polynomials are continuous. So when I plug in 2, I get a negative number, which is below the x-axis. I plug in 3, I get a positive number, which is above the x-axis. Remember, continuous means there's no holes or no gaps, right? And because it's a function, right, it can't do something like this and come back and cross over here and then come back and cross here, because it wouldn't pass the vertical line test. So I have to be able to go from here to here, and I can't again double back. I have to create a function that passes the vertical line test. So the only choice I have is to cross over somewhere between the two. That's what this is saying. Because we're negative at 2, we're positive at 3, some number in there creates a 0. Alright, so that's all it's saying. It's just existence. Okay. Then there is at least one. It doesn't tell you what it is. It's just like there exists some number between there that gives us 0. And when you do this problem in your homework, it's fine to plug it into your calculator. Zoom 6 to graph it in there, and then you can use the trace feature. So trace, I plug in 2, I type in 2. After I press trace, it gives me the negative 1. I press 3 and hit enter. It's out of the screen. Okay, we can't see it, doesn't put a cursor on it, but we can see the y value is 16. So when you do this problem on your calculator, on your homework, it's fine to use the calculator to help you. But you know, again, it's not mathematical. The math isn't that tough. Just plugging in the numbers and doing it by hand. All right, now graphing a polynomial function. So when you graph, like if you want to sketch a graph of a polynomial function, these 5 steps will give you a good idea, a rough sketch of what this thing looks like. And you see what the 5 are. It's leading coefficient test. Okay, get the end behavior right. That's really vitally important that you can do this one. All right, and then find the x-intercepts. So we're going to be able to factor for right now to be able to do this, but eventually we're going to be able to go a little bit further with it if it's not factorable. Okay, but we need multiplicities and the zeros. That's the second big thing we need. Alright, the y-intercept, plug in 0 to get the y-intercept. Symmetry, remember if we have even functions, if all the powers are even, we have y-axis symmetry. If all the powers are odd and there's no constant, then we have origin symmetry. And then the number of bends is always one less than degree. So all those things together will help us graph this thing. But really the really important things are 1, 2, 3, and 5. Right? The symmetry, that'll come from just getting all the other points right. Alright, so let's look at this thing. Even, this is a constant, so it's considered even. So all the powers are even, so this is going to have y-axis symmetry. Alright, in behavior. Even degree, positive leading coefficient, so I know it's going to rise on the left side and the right side. Alright, now the zeros. X to the fourth minus 2x squared plus 1. This is not quadratic, but it's what we call quadratic in form, meaning that the power on the highest term is double the power on the middle term. So this can be factored. Alright, so this is x to the fourth. When you have something quadratic in form, instead of x and x, you'll have x squared and x squared. And then I need two numbers that multiply to positive 1 and add negative 2. Well, that's just negative 1 and negative 1. So x squared minus 1, that can be factored to x plus 1, x minus 1 for this, and then the same thing for this, x plus 1, x minus 1. So I'm going to group the x plus 1's together, x plus 1 squared, the x minus 1's together. So that's x equals negative 1 would make this equal to 0. X equals positive 1 would make this equal to 0. So I didn't write it in here, but basically what I was doing here the whole way is finding the zeros, so setting this equal to 0. But this came from a power parentheses where the power was 2, so this is multiplicity 2. And so is this. So remember, multiplicity 2, that means it's going to touch and turn for both of these. Alright, so I got my end behavior. I know my zeros are negative 1 and positive 1. And I know it's got to touch and turn there. So it's either going to do this, or it's going to do this, or some combination, down, down, up, up. Okay? Alright, now what's going to be the tiebreaker? What's going to let us know if you can't already tell from the end behavior? It's not going to be this, but what's going to be the tiebreaker is the y-intercept. F of 0, plugging in 0 into this thing, gives me 0 to the fourth, which is 0, minus 2 times 0 squared, which is 0, plus 1. So f of 0 equals 1. So I can tell now that it can't be this, because it has to go up on the left side, it has to go up on the right side, it has to go up in the middle. The only way for me to do that and touch these things is for it to do like this. So touch here, go up, touch here, and then it rises to the right, and it rises to the left. Alright, and then don't forget you have your calculator. So if I plug this into the calculator, zoom 6, again to get back to the standard window, I see basically what I have drawn there. Okay, so like I was saying, I did mention at the beginning that I would have y-axis symmetry. I didn't really use it. I plugged in, I found the zeros on the x-axis. I found their multiplicity, so I knew it had to go up and up. I found the end behavior, so I knew what it did on the right and left side. I found that y-intercept and graphed it. The y-axis symmetry comes from all the other stuff. Okay. So anyway, that's that's what this 5-step process is trying to show you how to do. Come up with a sketch of these things using the zeros, their multiplicities, the end behavior. Alright, but don't forget, you got a calculator, okay? Your calculator can graph these things and give you not just a sketch, but a very accurate graph of what this thing looks like.